I'll show you how sediments are formed, and I'm going to use my one of my very complex scientific tools right there, my miniature ocean. That's my milkshake. Want a few sips? No. No, you don't? Ah, that nice fresh taste of mud and sand. I love it. Okay. This is a mini ocean, so you know you have land masses, you have rivers, delta, and sediment. Eventually, when they meet a bigger body of water, like the Gulf of St. Lawrence or even oceans, particles will settle, and they settle at different speed depending on their size. We already see some sedimentation happening here, which is bigger sediment or smaller sediment, would you say?
Bigger.
The bigger one is mostly the sand that is settling down right here. But what we have on top is the mud, which is slowly settling down. Well, the same thing happens in our ocean. Sand and bigger sediment settle first, and mud will travel a bit further and settle in deeper waters. So that's what's happening. Now, when sedimentation happens, you have layers over layers over layers. I'll take more complex scientific tools, my sponges, to show a few layers. So that's what's happening here. Layers of sediment, mud in the case of shell, would accumulate after each other like that. In this demonstration, the youngest layers would be which color?
Red.
Right. Now, this is what happens, and there's two main processes in the creation of sedimentary rock, which we call diagenesis. So sediments become sedimentary rocks, and it's compaction and cementation. So material like mud, as we were briefly discussing, they compact, but they keep their flaky structure, which will create a rock with flakes, while limestone is crushed and it becomes more of a uniform rock. So that's compaction, that's cementation. And then what happened for Greenpoint is either this kind of overturn more than 90 degrees, or on the opposite, maybe kind of almost turn to 90 degrees, maybe 80 degrees. So if it overturned, we'd be walking towards younger rocks. If it turns this way, you'd be walking towards older rocks. Now, how do you, as geologists, figure out the age of rocks? There's a couple different ways. One is to study, well, I should let you answer now that you're a geologist. So what was your insights?
Was it carbon dating?
Right, absolutely, yeah.
Also with the life forms that were in the rock.
Gosh, I don't need to talk anymore. Well, we'll do it as a group talk. But basically, look at the life forms. So in layers of rock, you'll find fossil. And some of the fossil, you know, could be found throughout the world. And you clearly know which, you know, time they were at. And then you put them in relation. So that's relative dating. The other one, carbon dating, is isotopic dating. You do it with carbon, we do it with zircon, with different minerals, where you look at the atomic structure, and some of the electrons are moving for a longer time, period of time, radioactiveness really, and it takes a long time for these electrons to decay, and that's isotopic dating. That gives you a pretty accurate dating, and you take core samples of rocks, and then you take a couple of one, and then you figure it out. So there's two main types of dating rocks, radiometry or radiotopic dating, and relative dating, and sometimes there's also visuals that kind of give you cues of what happened, because here we're in layers, there's some sort of currents, and I'll just show you a visual. Actually, I'll show you how to find the visual, and I'll let you find the visual. I decided to put a bit of technology in my program, because now younger generation use technology, so I brought my iPad. It's one of the first version. Okay, we'll see how the button works. Okay, it's on. Perfect. So that's my little iPad, and I like to demonstrate something for you guys that happened on some of the layers here. First of all, I have a question for you. Who's been on a beach here before? Raise your hand. Okay, we've all been on a beach. Now, who's been to the beautiful beaches of Shallow Bay and Western Brook? Just under the park. Don't miss them. Beautiful sunny beach out there. And sometime on the beach, when you look, especially at the intertidal zone, the tidal goes up and down, you see in the sand little ripple marks. So you know the sand goes in layers, but sometimes there's a little ripple mark, and sometimes the water collects in there at high and low tide, and so you know you have a little ripple mark like that. And the same thing happens too in the bottom of the ocean. And in some of the layers here of limestone, some of these little ripple marks have been preserved. And it's hard to find, but usually the point here head, you know, is on one side. It's like mini sand dunes, and the point here section would show you where youngest rocks are. So I'm going to invite now Young and Young our geologist to look at some layers of limestone right where we are. So the one between your feet, exactly where you guys are standing, is easier